So we're going to be working on page 11 here. Page 11, we're going to be doing a whole bunch of stuff with each one of these equations. First, we're going to write it in vertex form without using technology. So that means you're going to do completing the square, or you're going to find the vertex using negative b over 2a. State the coordinates of the vertex, okay. Find the y-intercept, okay. And sketch. And then use technology to check your answers. I won't do that on every single one, but a couple times I will use technology so you can see how to use that to remind you of how to do that with the calculator. Maybe this time I'll show you how to use second calc. 0. Okay, so let's look at the first one. The A value is 2, the B value is 4, and the C value is 5. If I was going to do this with completing the square, it's a little bit challenging because the A value is not 1, it's 2. So I'm going to do this one with completing the square just so you can see how to do that. So first thing I'm going to do is I'm going to factor out the A value from the first two terms. And I'm going to leave a space, and then I'm going to leave the plus 5 there. Kind of like before, remember how we left that space with plus 5? For some reason, we didn't touch the plus 5, right? And we're going to do the same thing here. It's easier to figure out the magic number if we just ignore the plus 5 and we don't put it inside here or multiply it or factor out the 2, okay? So we're going to add the magic number. If we take the B value and divide it by 2, it's 1, and we square it, it's 1 squared, which is 1. So I'm going to do plus 1 and minus 1 immediately so that it's the same thing as adding 0, okay? Then what I'm going to do is I'm going to group the A value 2 with everything except for the last negative one, and then I'm going to make a separate grouping where the A value is multiplied times the negative one by itself. So do you see how the 2 needs to be distributed to every single one of these terms? So there has to be a 2 times a negative 1. It can't just be negative 1 like last time, right? Okay? So now I have a perfect square here. I can factor it. It becomes x plus 1 squared. The A value is 2. And then I can combine these two constant terms. 2 times negative 1 is negative 2, plus 5 is plus 3. Okay? So I am done completing the square. And the vertex, apparently, from looking at this, is negative 1, comma 3, right? Because this is net minus negative 1, and this is plus 3. So I have the vertex value. The y-intercept value, of course, is the c value right there. So the y-intercept is c. It's 1, I mean. And last of all, sketch the graph of the quadratic and use technology to check your answers. So if I was to draw this here, the vertex is negative 1, comma 3. And it is turned up, and it is a equals 2 parabola, which means it's very tall. Instead of going up 1, 1, 2, 4, it goes up 1, 2, 2, 8. Kind of like that. So if I was to draw it, it would be tall and skinny, and it opens up. Oh, I'm sorry. I said the y-intercept was 1, but actually its y-intercept is 5, right? Because this one's 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, okay. So there's my y-intercept right there, right? Okay? My axes are very wavy, so didn't really go through the right place. So that was A. Now I'm going to do B. Or C, I'm sorry. C. So C is 2x squared minus 6x plus 1. again, to find the vertex form, we do not need to use completing the square. Especially in this case, they didn't even ask us to complete the square. So we could definitely use alternative methods such as negative b over 2a. So let's do negative b over 2a on this thing. Negative b would be negative negative 6, right? And 2a would be 2 times 2. So that is equal to 6 divided by 4, which is equal to 1.5. So in this particular case, the x value is 1.5 for the vertex, and the y value we can find by substituting in the formula. So y equals 2 times 1.5 squared. 1.5 squared is 2.25 minus 6 times 1.5 plus 1. And 2 times 2.25 is equal to 4.5. Minus 6 times 1.5 is equal to negative 9 plus 1. So 4.5 minus 9 is negative 4.5 plus 1 is negative 3.5 is the y value. So the vertex turns out to be 1.5 comma negative 3.5. And if we wanted to write it in vertex form, we would write y equals, and what's our a value? Our a value is 2. So we need to make sure we put our a value here. X minus 1.5 squared minus 3.5. So this will be the equation for the second graph. So I'm going to draw the axes. I'm going to mark the vertex, which is at 1.5 comma negative 3.5 right there. And this is a equals 2 parabola, which opens up, so that means it's going to be about like that. Okay. Oh, what's the c value, by the way, or what's the y-intercept? The y-intercept is plus 1. Oh, really? So it should be right there. Okay, kind of like that. All right, let's look at E. Negative x squared plus 4x plus 2. So if we were going to find the vertex, it would be negative 4 over 2 times a, which is negative 2. It's equal to positive 2. So our x value is positive 2 for the vertex. The y value would be equal to negative 2 squared, which is negative 4, plus 4 times x, which would be plus 8, plus 2. So I got 10 minus 4, which is positive 6. So our vertex is going to be 2 comma 6. And our vertex form is going to be negative, because our a value is negative, x minus 2 squared plus 6. And let's see, we're going to graph this. The vertex is going to be at 2 comma 6. And it opens down, and it's a value of absolute value 1, so it's going to be about like that. Okay. All right. Oh, we did not do a calculator verification. Let's do that for one of these. Let's put the c value in here. We'll put 2 x minus 1.5 oops, 1.5 squared minus 3.5. We'll graph it. That looks about right. If I want to check some stuff, I could do second table. It's the best way. And I could maybe make sure that some of my points are correct. For example, 0, 1, yeah, we got that one. 1, negative 3. That looks about right. 2, negative 3. Yep. 3, 1. 1. Yep. Okay. And if we want to find the vertex, we can see that these are symmetric. So the vertex appears to be at 1.5, right? If I wanted to, I could do plus 0.5, change the step size, and now I can see that the vertex has a y value of negative 3.5, right? Okay, so that's how you can use the calculator to check some stuff. One thing we could do is we could also check to see that the zeros are using second calc 0. So we could do second calc 0, number 2, and when we're going to try and find this one, okay? So we can move the cursor so that it's to the left of the 0. So I'm going to hit enter, and then I'm going to move it to the right of the 0. To the right. Enter. Guess, doesn't matter where you guess. So it's the 0 value is 2.82, 0. Okay? If you happen to care. Okay? Alright, what's the last thing they ask us? Number 3. Use the graphing package or your graphics calculator to determine the vertex of each of the following functions, hence write the function in the form y equals a times x minus h quantity squared plus k. Okay, so now we're just going to use the calculator to do these. So we're going to do y equals, clear that, and I'm going to just write exactly what they got there. X squared minus 4x plus 7. And I am going to graph it. And then I need to find the vertex. The vertex I can find by doing second calc min. Enter. And then I'm going to mark the left side and the right side of the vertex. And so first it's asking for the left. It's already left of the vertex. So I just hit enter. And then it asks for the right, so I'm going to move the cursor to the right. Okay, and then I hit enter. And then it asks me for a guess, doesn't matter where the guess is, so I just hit enter. So the minimum value happens to be 2, 3, and that also should be the vertex, okay? And so what I do is I'm going to write the HK form here. And what's the A value here? The A value is just 1. So the A value in the A value in the standard form is the same as the A value in the vertex form. So I know that it's 1. So here I'm going to put x minus 2 squared because the h value is 2, and then I'm going to do plus 3. Okay. E. So I got negative 2x squared minus 10x plus 1. Once again, I'm just going to type this in here, clear that, put negative 2, and when you put negative, when you put a leading minus sign, you need to use that one. Okay, I got it in there. I'm going to graph it. The vertex is off the screen, so I need to adjust it a little bit. Maybe the easiest way is just to use window. I'm going to change my y max to something bigger than 10. So I'm going to put maybe 15. Let's see if now it's on the screen. It is. So now what I'm going to do is I'm going to find second calc max to find where the vertex is. So second calc max, which is number 4. And then I'm going to move the cursor to the left of the vertex. Just tap it a few times. Hit enter. Then I go to the right of the vertex. Enter. Guess, press enter. Doesn't matter where guess is. So the max is negative 2.5 comma 13.5. So I'm going to write that down. Negative 2.5 comma 13.5. And if I wanted to write that in slope-intercept form, I would put the a value first, which turns out to be negative 2, right? Then I would do x minus negative 2.5, or x plus 2.5 squared, plus 13.5. Okay? So that's my HK form, or my vertex form. Last of all, negative x squared plus 4x plus 5. Again, let's type that in here. Negative x squared plus 4x plus 5. Oops. Plus 5. Okay, and then I'm going to graph it. And then I'm going to find the vertex. So I'm going to do second calc max, which is number 4. Left bound there is fine. I hit enter, and then I use the cursor. Move the cursor a little bit to the right, so that's the right of the vertex. Enter. Guess, doesn't matter where, you just hit enter. 2, 9. So here, the vertex is going to be 2, 9. And if I was to write this in HK form, I would put negative for the a value, and then I would put x minus 2 squared plus 9. Last of all, what is the relationship between the discriminant and the quadratic equation? Okay, the quadratic equation, we all know from looking at the formula sheet that it kind of looks like this. Right? And the discriminant we know is equal to b squared minus 4ac. Well, guess what? Right? So the discriminant, delta, is equal to the inside of the square root of the quadratic formula. So that is why the discriminant has so much power. If the yellow part ends up being 0, then it would be negative b plus or minus 0. So there would only be one x-intercept, which is when the parabola exactly touches the x-axis, right? If b squared minus 4ac is a positive number, then great, square root of a positive number is also a positive number. So then you have two x-intercepts that are real. And if b squared minus 4ac happens to be a negative number, then you end up with square root of like negative 5. If you have square root of negative 5, the thing blows up, right? We cannot get the square root of a negative number. Okay, so to answer the questions, they said discriminant is under square root of quadratic formula. Okay. What happens when the discriminant is negative? When the discriminant is negative, then no solution to x, right? So the parabola will just float above the x-axis or float below the x-axis. It will not cross the x-axis if the discriminant is less than 0. And that's it for this page.